Hi everyone. So, on this video I will be explaining how to do a projectile motion problem with no initial velocity. So the problem reads, a projectile is to be launched at an angle of 30 degrees so that it falls beyond a pond of length of 20 meters as shown in the figure. What is the value of the initial velocity so that the projectile falls between the points M and N, which is at 35 meters? So, the very first thing we always do is to begin with the frame of reference. We will trace our x and y axis at the origin where VO starts. Okay, what's next? To level up everything we know. So, we know that the distance here from here to here is 35 meters. 35 meters. We don't know the time, so we will name it t. That's all we know at this position. Now, if we place ourselves at the maximum height, we know that at the maximum height, the velocity on y is always 0. So we know that Vy equals 0. Now, because it lands and it's being launched at the same height, the time it takes to reach the maximum height is exactly the same time that it will take from the maximum height to the end. So, the time it will take from here to here is just the half time of the entire travel. So we know that the time here is t divided by 2. That's all the information we can get from the problem. Now, if we go back to vectors, we can name these two components as Vox and Voy, which is the horizontal component of the initial velocity and the vertical component of the initial velocity. From previous topics, we know that Vox equals to the magnitude of VO that we don't know, but it's named VO, times the cosine of the angle. In this case, 30 degrees. So times the cosine of 30 degrees. This is 0.86 VO. Now, the y component is exactly the same, but with the sign. So Voy, the vertical component of the initial velocity, equals to the magnitude of the initial velocity that we don't know, times the sine of the angle. In this case, the angle is 30, times the sine of 30. This equals to 0.5 VO. Now, we can divide the problem in two parts, the horizontal part and the vertical part. We know that the horizontal distance traveled is 35 meters. So, because of that, and because on x it is a motion, it is an unaccelerated motion, we can go directly to it. So, we will begin with x, on x. For unaccelerated motion, we can use this formula. Delta x equals to Vx times t. Now, if we substitute the values that we know that the total displacement on x from the origin up to where it lands is 35 meters. So 35 equals 2. We don't know Vx, but we know that Vx in terms of VO is 0.86 VO. So that's what I'll be doing. 0.86 VO. Then this times the time. Now, I will solve for VO. So the t and the 0.86 that are multiplying VO, I will pass them to the other side dividing. So we will have that 35 divided by 0.86 t equals to VO. Now, that's all we can get from this point. Now let's go to this position, the position when we have the maximum height. And that motion is on y. Let's divide this. Okay, on y. On y, we know that the velocity is 0 and the time is t divided by 2. The formula that will help us with time and velocity is big for number 2. That says Vy equals to Voy plus gt. Now, we know that the velocity at that point is 0. So 0 equals to, the initial velocity on y is 0.5 Vo. We don't know Vo, but we can substitute it like this, 0.5 Vo. Plus, the acceleration due to gravity is a constant, that is minus 9.81. And finally, the time we have is t divided by 2. Now, if we do a little math and we substitute Vo, we will have the following. So 0 equals to 0.5, and I will substitute this Vo. For this value, we know that it's Vo. Okay? So, and I'll put it in green so you remember. 0.5 times 35 divided by 0.86 t. Then plus, and I will make this multiplication already. Minus 9.81 divided by 2, that is 4.905 t. Now remember that this is negative, so it will turn everything into negative right here. So minus. Then we can do a little bit more of math. I will multiply the 0.5 times the 35. So 0 equals to 0.5 times 35 is 17.5. 17.5 divided by 0.86 t minus 4.905 t. The next part is we will be solving for t, but we have a t that is under a fraction. So I will move the entire fraction to the other side and it will turn negative. So we will have that minus 17.5 divided by 0.86 t equals to minus 4.905 t. The next part is I'll put all the t's on the same side. This t is dividing, so it'll pass to the other side as multiplication. So we have minus 17.5 equals to minus 4.905 t times 0.86 t. The way we multiply this will be 4.905 times 0.86 and then t times t, that gives us t squared. So minus 17.5 equals to 4.22 t squared. 4.22 t squared. Negative, because of this negative. Now, I will pass this dividing to the other side. So we will have minus 17.5 divided by minus 4.22. This equals to t squared. Okay? And finally, I will do it right here. We will have that t squared equals to 4.15 And in order to remove this power, I will make a root. So t equals to the square root of 4.15. Now that we have that the time equals to 2.03, 2.03 seconds, we will substitute this value in this t. So we can get VO, and finally we can get the answer. So VO equals to 35 divided by 0.86 times 2.03. And this equals to 19.91 meters per second. And that would be the answer. In order for this projectile to be launched at 30 degrees and land 35 meters above, it will require an initial velocity of 19.91 meters per second. Thanks for watching.